Everyone. Today we're going to be going through tutorial 7, hypothesis testing for PSYC1040. This recording is meant for those students who were unable to attend their tutorials last week due to the Labor Day public holiday. Uh, if you can still watch this, I suppose, if even if you did already attend a tutorial, just to consolidate your understanding. But in essence, if you had any questions, I may not actually be your regular standing tutor. We have 3 other classes on Monday. So if you had any questions, feel free to shoot me or your corresponding tutor an email throughout this lesson. So what are we going to be doing today? We're going to be looking at research report information. Let me just pull out my cursor here, as you can see. We're going to be looking at the appendices section, describing the abstract, what we need from you for the abstract section, and we're going to be talking a little bit about writing as well. And then we'll move on to hypothesis testing. And we're not actually going to do the worksheet exercise because the answers and solutions for these worked solutions, sorry, will already be up on Blackboard by the time this recording goes up. So I urge you afterwards, since you're going to receive the lecture as well as the background on hypothesis testing for this tutorial after you finish watching this video, I recommend that you complete the worksheet exercise without looking at the answers and then check yourself. And then if you found any of the steps difficult, if you really are struggling, then just send your tutors an email or wait until class for your queries, because we do work through these in class quite thoroughly. So you have those couple of options. So let's begin. So we're going to start with research report info on the appendices and the abstract. So the appendices section of a paper usually contains additional material that supports your main report. Now, it may include your raw data, extended analyses, technical details, basically any kind of supplementary information for your reader. Uh, Specifically for readers who want to dive deeper into the subject or examine how the specifics of the study were run. So if this could be supplementary or exploratory analyses, anything that you want to describe in the methodology in more detail. It basically, the appendices, it allows easy access to supporting info without cluttering your main report. And it doesn't, the omission of features from the main report into the appendices should not take away from the main thread of your paper. This is what we need from you. So we want you to include the raw data, please. This can be directly copied and pasted from Excel. Just make sure you make it neat. No need to APA format this table. It's a huge table. So see if you can find a way to present it in maybe perhaps 2 or 3 pages. Make sure you include every single questionnaire and scale that was given to the participants. Okay. Now you should have access to this via Blackboard. Create an APA formatted scatterplot figure for each hypothesis, noting impossible scores. Now this is critical in some way. Okay, so typically in APA formatted figures, we have the figure number, the figure title, the figure itself, and then underneath we have a little note to give a little bit more information about the figure to the reader. In this little note, you can just indicate that impossible scores have been identified from this plot by something like the scores that are far away from the main cluster of points, or the scores that are past certain such and such cutoffs. Okay, there's no need to recolor them or reformat them in any way, so long as they're there and that you mention that the impossible scores have been noted in some way. Okay, then you include your computations in a single appendix, and this is quite critical. A little more information. So make sure you label each appendix using letters. So appendix A and B and so on. This just helps with APA formatting. Each appendix should start on a new page, and your scatter plots have, as much as possible, to be APA formatted figures. So you can look at the APA style website for this, and we also have the APA cheat sheet later on with relevant links for you. For your computations, not try, but please use this formula. So you report the formula, you report the product sum, as well as the number of paired scores. So this formula can be reported just once, okay, and you'll get the full marks for it. However, the product sum the number of paired scores will not be to any decimal place because it's an integer, but the product sum has to be reported correctly to 4 decimal places for all two analyses. Apologies, so this should be 2. So the abstract provides a brief overview of the study. It's basically a nice little summary of the study that includes the purpose, the methods, the main results, and the conclusions of the study. And it's used so that people can quickly grasp the essence of the research that was conducted. Here's what we require of you. So please provide a brief overview or background. This can be 1 to 2 sentences that just contextualize the study. Please outline the aim of the study. What did we set out to investigate? And this ties directly to to an overview of your hypotheses. We don't need you to explicitly state that you expected a strong or a positive or a negative correlation for your two hypotheses. We just need you to be a little bit general. Okay, you can be a little bit general about these 2 points. So maybe 2 to 3 sentences. Make sure you describe the methodology. So how many subjects were tested? So make sure you include your N in there, your total N. And who were they? Who was the sample? Make sure you also mention what scales were administered to the subjects and report the key results. So you can report the correlations using R bracket with the number of paired scores equals whatever your R value is, or you can just report the shared variance percentage. But just remember that if you report the shared variance percentage, this has no indication of direction. So make sure you mention the direction somewhere if you choose to report the shared variance percentage to get your results mark. As well, please make sure to link your findings back to your main hypotheses and to provide a concluding statement. Okay, these are all very important. These will take about 2 to 3 sentences as well. So, and critically, here's a nice little example. This isn't going to be a perfect abstract in the context of your report since it's a different paradigm, but this is the general gist of what an abstract should sound like. So here is their starting statement. Social media use has increased in the last decade, and its impacts on mental health are still not fully understood. We examined the relationship between social media usage and self-esteem among young adults, predicting a negative correlation between these variables. So here they've stated the aim of the study, the aim and the rationale of the study, as well as their predictions of the outcomes. A sample of second-year medical students from the University of Ontario, N equals 150, there's their N, completed an online survey comprising this scale as well as this scale. As hypothesized, the results revealed a strong negative correlation between the two scales, and here they've already mentioned the variance as well as the direction. Okay, so 16.81% of the variance in self-esteem can be explained by social media usage. However, these findings indicate that higher social media usage is associated with lower self-esteem among young adults, highlighting the potential negative impact of excessive social media use on your well-being. Further research is needed to explore the underlying causal mechanisms and develop interventions to mitigate these effects. So this is a nice little neat conclusion. It might be missing a few components that we mentioned from the previous slide, but this should be the general gist of what an abstract should sound like. Your abstract is the only section in your report that has to be that has a word limit. So the abstract has to be contained in less than 200 words or less. Okay. Make sure you're precise and concise and write only what you need to get across, and that the abstract is the only body paragraph. This is just for APA formatting purposes. It's the only body paragraph that is not indented on the first line. Okay. So let's move on to writing. Now, when you're writing, drafting is not going to be editing. You're most likely not going to write perfect sentences on your first draft. So make sure you get your ideas down first and edit afterwards. Some of the best work that gets put out are works that take time, right? And your first draft is going to be, inevitably, it's going to be a little bit sloppy. You're going to start just writing everything that you know down. And editing is for cutting down and making things more precise, streamlining it, adding things. Make sure you differentiate these two as you write your feature papers. Make sure you delay rereading as well. Your cognitive state when you read it the first time after you draft is not going to be, ties into drafting, is not editing. It's not going to be the same read over. It's not going to be the same cognitive state as you will be in when you read it a second time. So it's best to wait at least a day or two after you draft, and then read it again aloud. So this is why it's also useful to start assignments fairly early, so that you can go through the drafting and the writing process and not panic because there's only a day left before submission. Right? Now, you're also allowed to write in first person for scientific papers. Make sure you write in the active voice. You balance these two out, but generally we prefer that you write in active voice. So passive voice is something like uh, there's no action, there's no thing or person taking action on the main clause of the sentence. I think that's correct. The clause of the sentence. So, for example, this experiment was conducted to measure the effects of antidepressants on adolescent depression. So in this case, this experiment was conducted. Who conducted the experiment? What was the experiment conducted by? Yes, it's an okay sentence, but if you wanted to represent it with an active voice, you could say we or I conducted an experiment to measure the effects of antidepressants on adolescent depression. It just feels stronger because there's something that we can tie to the action, and a good balance of these two forms of voice will help your report flow a little bit better. Now, speaking of flow, if I find it difficult to understand your point, if your tutors find it difficult to, comprehend your writing, you will lose marks. Writing any unnecessary detail will be penalized in the writing quality marks. So please make sure you're coherent and concise, and that your writing flows from one paragraph to another and from one sentence to another. Now, here's an example of poor flow. Memory declines with age. Cognitive exercises can help. The elderly often experience social isolation. Social interaction is important for mental health. Some studies suggest a link between social activity and cognitive function. Now, you may be thinking, you already know what's wrong with this little paragraph, and it's just the short, jarring sentences that don't really have anything to do with each other, and the writer just assumes that you'll link these ideas with each other at some stage. However, here's an example of better flow. Okay. While memory typically declines with age, some studies suggest that both cognitive exercises and social interaction can help maintain memory in the elderly, potentially mitigating the effects of social isolation. Now, the point of this little example of flow is not that condensing many things into a single sentence always necessarily leads to better flow. It's just to demonstrate how simply noting down points in successive, unconnected sentences can be a little bit jarring to a reader. And a good balance of punchy sentences that lead into each other and long sentences that flow nicely will also help furnish your writing, your future writing, whatever paper it might be. Okay. So let's move on to APA styling. So I've created a cheat sheet here, a bit of a cheat sheet that you can just go back to while you're writing your report. Maybe you're finishing up your analyses, and you've pretty much done everything. Try to leave formatting to the very end because it's kind of the easiest marks that you can obtain. So in this case, we have a title page. The title page is allocated its own page and includes the title of your paper, your name, the course name, and your tutor's name. Okay, so this content should roughly be in the center of the page. The running head has two components. So in the left aligned, in the left, all the way to the left, you have to have a version of the title in all caps, and to the right, directly to the right of the title in all caps, is the page number. Make sure you use a font that's legible. You can use any of these fonts or any that are available on the APA style website. Make sure that your paper is double spaced with no extra space between paragraphs. As well, Word does this by default already. Just double check that the margins on all pages are 1 inch. Now, headings are very important in APA. It helps delineate each section and subsection from the rest. So your paper will probably only ever require 2 or 3 heading levels. So level 1 headings are centered, bold, and in title case. So the major words are capitalized in the first letter. They're used for the main sections of a paper, like your introduction, your method, your results, and your discussion. However, your introduction's heading is just the title of the paper, and this is critical. It's not introduction, it's whatever title that you give your paper in level 1 format. Level 2 headings are left aligned, bold, and in title case. So same thing here. These are used for subsections within a main section. So for example, the participant subsection and all the other subsections in the method section. Now, finally, level 3 headings are left aligned, bold, and italicized, as well as in title case. So these are used for adding more specific details within a subsection. I doubt that you need to use level 3 subheadings. You can if you want to. You're not going to get marked down for it. But I guess for simplicity's sake, just stick to the level 1 and level 2 headings. Now, I recommend this to all of my classes, all of my students, that if you are unsure while writing, and you will be because APA formatting is it's not explicitly taught, check out the APA style website. Okay, in particular, these professional sample papers are really helpful for formatting your paper correctly. So these slides are already up on Blackboard. Just peruse them and click on this link to get access to the professional sample paper. And if you base your styling and formatting, not all of the components in the professional sample paper are going to be essential for your report, but if you just have this thing side by side next to your Word document, you'll be pretty okay with formatting. It's a free, like I said, APA formatting is usually a free 5 to 10% in most psychology assessments. So learning how to do this precisely just saves your just saves you from a lot of grief later on in the future, and just unnecessary practice if you learn it nicely in your first year courses. So on concision, a little bit more on writing. Okay, as a final note, concision refers to the principle of eliminating redundancy in writing. In science, we want to always be a little bit exact. We want to be precise in our expression. So make sure to use short, simple words in plain English when writing your report. Don't write any words that you don't know the meaning of. It kind of shows, and it particularly shows when it's used in a jarring manner. When it's like I don't know, when you put photosynthesis in a paragraph that doesn't need photosynthesis or something, right? So short, clear sentences are typically always better. I should have written typically here. So here's an example of a convoluted sentence. Do not try to predict those future events that will completely revolutionize society, because past history shows that it is the final outcome of minor events that unexpectedly surprises us more. At first glance, it seems like a perfectly reasonable, well-structured sentence, well-delivered sentence, but as you dive a little bit deeper, you'll notice that there are redundancies all across the sentence. So let's start. Do not try to predict those future events. Now, if we're predicting something, it's kind of already implying that it's gonna happen in the future. So we can probably cross out those future. So let's keep going. Do not try to predict events that will completely revolutionize society. Revolutions are already kind of fairly complete, and this is another thing that is the enemy of concision. It's adding unnecessary adverbs before main clauses or main nouns, right? So let's keep going. Do not try to predict events that will revolutionize society. Actually, in fact, we might be able to even get rid of will, that revolutionize society, because they want to make broad generalizing statements here. Because past history, straight away, isn't history already in the past? So let's get rid of past. Shows that it is the final outcome. Outcomes are already fairly final, so let's get rid of final. The outcome of minor events that unexpectedly surprises us more. Unexpectedly and surprise. If you're surprised, I mean, you wouldn't be surprised if you were expecting it. So let's just get rid of this unexpectedly. And actually, maybe it shows that it is the outcome of minor events. You know what? Let's just even get rid of outcome. Let's just make it minor events, because they never really said outcome of those future events over here. So That's just final outcome. It is minor events that surprise us more. Surprise, no S. Yep. Actually, we kept outcome here, but that should be fine. So yeah, the point of this exercise was essentially to show you that during your editing process, your editing stage, you will inevitably cut down, and particularly for the abstract, which is the only section that has a hard word count, you'll do better after rereading after your drafting phase. Okay, let's do another thing. Okay, the proliferation of nominalizations in a discursive formation may be an indication of a tendency toward pomposity and abstraction. What in the world does this mean? Right? It basically means that writers who overload their sentences with nominalizations tend to sound pompous and abstract. Pompous. Nanification is a chronic disease in professional writing. Adding a shun to everything does not make it sound any smarter than just saying the word. So the proliferation, the spread, you use a simpler word. Takes up less working memory, less cognitive resource. The spread maybe of turning things into nouns, nominalizations, in a discursive formation. In writing, discursive formation sounds so pompous, pompous and abstract at the same time, right? So try not to change things into nouns unnecessarily, and just write and say what you need to say, because as we established, short, clear sentences are typically always better. Perfect. So here are some final writing tips and resources. Make sure that you use clear, precise, concise language. This is the common thread in scientific writing. Make sure you structure your writing logically, and that each paragraph develops a single main idea. And as well, make sure you revise and you proofread. Now, these are some extra useful resources to improve your writing throughout your degree, as well as for this course. This book by Steven Pinker, The Thinking Person's Guide to Writing in the 21st Century, is excellent. I believe you can access it in the library, through the library, the online library. What helped me during my honors year was this free online course on writing in the sciences. It's free on Coursera, and it's hosted by Stanford University. Specifically, Dr. Kristen Sainani, who is, I believe, in the biological sciences. She's also a researcher. Basically, teaches you how to balance passive and active voice, how to interpret and convey complex scientific information, complex statistical information in a clear, coherent, and comprehensive manner. So this is if I had this in first year, I would have well, I would have preferred to have encountered this in first year than just before my honors year. You also have a course specific resource in your learning resources under the course reading list called How to Write Psychology Reports and Assignments by Kaufman et al. And this one is also a free resource. And finally, you have access to UQ's online library. So that's free papers on any topic that you can possibly think of. You have like this is a time, this is what, 3-4 years in your life, unless you're doing postgrad, it's more, but 3-4 years in your life when you have access to things that would normally sit behind a paywall, papers on any topic that you're interested in, you know, and depending on the field that you want to get into, it's probably a good idea to start reading psychology papers, papers that would spark your own interest, because well, you'll if you're planning on doing honors, you're gonna have to engage in research, all the way up, perhaps even up until masters, and throughout your life, we never really stop researching. So it's just really good to get used to reading papers on topics that interest you, because, well, it's you want to take advantage of this access, this 3 or 4 years, and your tuition is paying for something, and it's I suppose one of it is UQ subscription to countless journals. So, what are some frequently asked questions on this report? How do I add the full raw data scales of impossible scores in the appendix? Well, it's not going to be pretty. So actually, not impossible scores, but just the how do you add the anything into the appendix? Not really pretty, but just copy and paste. There's no need to APA format the raw data. Do you have to APA format your appendix? No, aside from your scatter plot figures. For your computations, do you need to show how you computed r squared? Yes. Yes, very critical. Do you delete the entire row if it's an impossible age? I don't know how many times I've gotten this question, but I think it's just a little bit of statistics anxiety, but that's okay. No, you only delete ages, the impossible ages, for describing age statistics. It's not going to affect your analyses. Excuse me. Now, do you need to reference any material outside of your report? No. What if you get a low correlation, like really low? Interpret all non-zero correlations. If you think it's an extremely low correlation, then say so. Make sure you refer to the lecture slides for definitions of various correlation magnitudes, okay? So we use PSYC1040 guidelines for interpreting correlations. How many decimal places do I have to report my statistics to? Now, you have to report it to 2 decimal places in the main report, but your computations have to be reported to 4. What do the instructions mean by describing how you explore the data and the results? Well, you just need to briefly describe how you screen and clean your data. This will take about 2 to 3 sentences. You know, what did you do? What platform did you, what program or what process did you take, you know, to identify those scores? They need to provide statistics for all the variables in the results? No, only the 4 that are relevant to your hypotheses. And finally, when you're calculating the standard deviation for your variables, you use n or n minus 1. Make sure you use n. We're treating the participants as the entire population of PSYC1040 students. Doubled up there. Now, that is the final, those are the final pieces of information that pertain to your report. So now you can go ahead and pretty much completely write it, get 100% on it. It's due in a couple of weeks' time, and you'll also get a final reminder in next week's tutorials and lectures that it is indeed due on this date. Let's move on to hypothesis testing. Okay. And I think the best way to, one of the good ways to present this is with a motivating example. Now, the average score in the general population on a new math test is 70. Okay, so mu, because it's population, and sigma is 18. Now, PSYC1040 students are known for their no doubt excellent math skills. Okay, a lecturer wanted to see if their students were representative of the population. So in a single tutorial class of 36 students, their average score was 75. Now, straight away we see that 75 is greater than 70, right? So these guys may already be smart, but why smarter than the rest of the population? But why is it necessary to perform a hypothesis test? So we have one main reason, and it's because if the students were truly average, random chance could easily produce a sample mean that is different from the population. It could have just been chance that we drew 75, a roll of the dice, right? Could have just been the universe being lucky. These students could have just been lucky today, that day that they took that test. With only 36 students, we want to account for how much variation we'd expect in small samples given the variability in the population. So we know the statistics, the parameters in the population, right? But these parameters apply to countless numbers of people. We only have 36 students, so we need to be able to account for that, for these smaller sample sizes. Now, finally, a hypothesis test is, I suppose this is the most critical point. It helps us determine if the observed difference of 5 that we see is large enough to confidently conclude that these students really are different from the general population, rather than it just being a chance occurrence. Specifically, we just want to rule out the possibility that the observed 75 being greater than 70 was purely due to luck or chance. We want to be able to rule out that possibility. So from our example, we can form 2 hypotheses. We have the null hypothesis that there is no difference between PSYC1040 students and the general population. So rephrasing this slightly, it means that our sample of students did indeed come from a population with mu equals 70. Any difference that we see between our sample mean and the population mean may just be random chance or sampling error. Our second hypothesis the alternative hypothesis, is that there is indeed a difference between Psych 1040 students and the general population. Maybe these guys are smart after all. Maybe they're smarter than the rest of the population. Who knows? In other words, rephrasing it, our sample came from perhaps a different population of scores with a higher or a lower mean. In this case, it's probably going to be higher if the alternate hypothesis is true, because 75 is greater than 70. That is, in other words, Psych 1040 students may be different from, or perhaps even better than, the general population at math. So before we answer that question, though, it's good to have a fundamental understanding of two important distributions that are distinct: the population distribution and the distribution of sample means. So math scores across the general population can be plotted in a single distribution called the population distribution. You can see that here, right? Population scores for 100,000 people, say that's the size of a small town or small city. And you can see that it's fairly normally distributed, right? The population, but your population distribution can be distributed in any which way. It can be positively skewed, negatively skewed, multimodal, what have you. It doesn't matter, so long as it is representative of the population. Now, let's say we take a random group of 36 people from this big population, gold population, and we plot their scores down here. And we get the average of their scores. And we get 69.48 as our mean, okay? So we have just taken our sample, and this is just any random group of 36 people from this population, okay? Let's do it again. Let's take another group of 36 people and then plot their scores. So that's another mean that we obtain, that little red bit. See, and we get 71.37. And these scores will be a little bit different from these scores. Let's do that again and again and again. Now, the rationale behind this is that, as we mentioned before, things tend to become normal over time, and the same is the case in particular for sampling means. Sampling 36 people an infinite number of times with replacement, right? So you replace them again and again, and we plot the means on each random sample of 36 people with replacement from the population. The plot of means gives us, unsurprisingly, the distribution of sample means. And it's called such because it's sampling again and again, 36 people, and you're taking the mean of those 36 people on whatever score it is, in this case it's math, and you're distributing it across a number line. It's basically counting how many sample means occur at particular levels in the number line. This is the basis for this branch of statistics, looking at the long-run frequency of things and forming conclusions based on this model. So what does this look like? What ends up happening is, according to central limit theorem, the mean mu of m, so again subscript m, pertains to the distribution of sample means, m for mean, so the mean of this thing, little gold, see there, is the same as the mean of the population distribution. So if we did this an infinite number of times, we would converge on a mean of the distribution of sample means that is exactly the same as the mean in our population. It's very neat, and it's a property of it's just one of the properties of large numbers, of large sampling. Notice also that the majority of sample means falls within the red, right? 95%. Now, this may be looking familiar already to you if you have some understanding of Z statistics. Now, using this distribution of sample means, we now have a model of the pattern and results we can expect for HO and H1, our null and our alternate hypotheses. This is because only a small percentage of samples are expected to have a mean in these tails, these blue tails of the distribution of sample means, of this entire distribution. What we're trying to figure out is where our sample mean is in this distribution. Is it close enough to the population mean that we can accept that the difference is just chance? Or is it far enough away for us to rule out chance? So where is the mean of 75 in this distribution? So going back, linking this to our hypotheses, if our mean of 75 falls within that little red bit, within the 95% intervals, we can conclude that our sample of students comes from the population distribution, from that population distribution wherein the mean was 70. Our alternate hypothesis, however, is that if mean of 75 falls outside that little red bit, i.e. in those little blue bits, we can conclude that our sample of students does not come from the population. Okay. So we now know that the distribution of sample means, because of central limit theorem, the law of large numbers, it ends up becoming normally distributed. It clusters around the population mean and eventually forms this wonderful Gaussian bell shape. Now we also know that its mean is just the same as the population mean. The mean of this thing is gold. The mean of the population is also gold. However, we cannot just use the variance in our gold population distribution, sigma squared, nor the population standard deviation, sigma, to represent the variability of this thing, of the distribution of sample means. So we now need to find the variance, denoted sigma with, again, that little subscript m pertaining to the distribution of sample means, and superscript 2, an exponent of 2, indicating that it is squared, so it is a variance statistic, and standard deviation, which is denoted sigma, again with that little subscript denoting that it pertains to the distribution of sample means. Once we obtain the variance of this thing, correspondingly, we can then easily compute the standard deviation of this thing, because the standard deviation, if we recall, is always just the square root of the variance. The standard deviation of this thing, therefore, is called the standard error of the mean. And you would have already known this from the lectures, but it essentially represents the average error there is every time we take a sample from the population of that size. Okay, how much are we making an error? If you know the parameters of the population and the size of your sample, you can compute the variance of that distribution in the previous slide, right? And subsequently conduct your single sample z-test. So here's how we compute the variance of the distribution of sample means, denoted sigma subscript m squared. It's equal to the variance of the population divided by the size of your sample. Now, importantly, from the population parameters, you can compute the standard deviation of the distribution of sample means. Like we said before, it's just known as the standard error of the mean. And there's a couple of ways that you can do that. So you can use the population variance, plug it straight in, or you can use the population standard deviation, and you would get the same result. So let's just use these two equations to derive standard errors of the mean for our toy example. So in this case, we are plugging in the the variance of the population, which we know is 18, squared. Remember squared. Don't forget to square your standard deviation, because again, this is a standard deviation because it's just sigma. There's no exponent 2, and we get a standard error of the mean of 3. For the population, using the population standard deviation, you can just plug it straight in and just divide by the square root of n. You don't need to square it here. And sometimes this actually may introduce this extra step of needing to square a supplied standard deviation in an exam question may actually introduce unnecessary errors. So to keep things simple, if you're given the standard deviation, for example, in an exam question of the population, and you need to compute a standard error of the mean estimate, then just plug the standard deviation straight in and just divide by the square root of n, as is the case here, and you'll get the exact same standard error of the mean. From here, we can conduct our single sample z-test. So our z-test is just the sample mean subtracting, or the observed sample mean subtracting the population mean, or the mean of the distribution of sample means, denoted mu subscript m, divided by the standard error of the mean. Okay, so this is now a standard deviation. We've got this. We now have our denominator for this equation. We also have our sample mean and our population mean, and we get a z-score of 1.67. Now, our z of 1.96 is very important here, and we know why this is important. It's because anything past 47.5 from the mean to z of 1.96 means that we are now in the tails of the distribution. We are now in the blue bits. Okay, so 1.96 represents z-score cutoffs on our number line for rejection or retaining of the null hypothesis. Now that we have z of 1.67 over here, right, we know that it's less than 1.96. Therefore, can we rule out chance, or is it too close to the population mean to rule out chance? Yes, obviously, it's within the little red bits. It's within our criteria for retaining the null hypothesis. So therefore, there is no difference between PSYC1040 students and the remainder of the population. Okay? So again, I urge you to complete these exercises without looking at the answers first, and then once you've completed the entire worksheet, go through the work solutions. And if you have any confusions, just email your tutors, email me, um, and we'll see if we can help you out. So that should give you a fairly nice overview of an introduction into estimating the standard error of the mean and hypothesis testing.